Okay, now we have a Dr. Ashutosh Mandpe, sir. Ashutosh Mandpe serves as an assistant professor in civil engineering department at the Indian Institute of Technology, Indore, where he has been inspiring and educating further energies since October 2021. With over 10 years of experience in environmental engineering and science, he has contributed significantly to the field, especially in solid waste management. Dr. Mandpe earned his PhD in engineering from the Academy of Scientific and Innovative Research with an impressive CGPA of 9.53 in April 2021. His doctoral research was conducted at the prestigious CSIR National Environment Engineering Research Institute, Niri, Nagpur, under the guidance of Dr. Sunil Kumar. Dr. Mandpe holds a master's degree in Environmental and Water Resources Engineering from the College of Engineering, Pune, and bachelor degree in Civil Engineering from the University of Pune, graduating with first class and distinction. He has presented his research at numerous international conferences, earning several accolades. Additionally, his publication in high impact SCI Index Journal highlight his contribution to advancing environmental solutions critical for sustainability. Dr. Ashutosh Mandpe has received several prestigious accolades, including CSIR Direct SRA Fellowship 2019-20, NFSC 2020 Fellowship by University Grant Commission, Best Young Research Award 2019, DST Serve International Travel Support Grant to present his research at the 34th International Conference on Solid Waste Technology and Management USA, Baba Sahib Ambedkar National Research Fellowship 2015 from Bharati Government of Maharashtra for his doctoral studies. I welcome you, sir, on the behalf of IPS Academy Civil Engineering Department. Kindly enlighten us with your words and your knowledge.
Firstly, I would like to thank IPS Academy coordinator and all the organizing team for giving me the opportunity. Also for your kind words and this detailed introduction. Yeah, so I'm just sharing my screen. Kindly let me know. Is my screen visible to you all?
Yes, sir.
Are my slides moving?
Yes, sir. Yes, sir.
So yeah, I would like to mention it's not an excuse. From last couple of weeks or like 3 weeks, I'm traveling continuously. Since I had committed here, I will try to do justice. As of now, I'm not in station. I am in like SVNIT Surat to attend. I mean to chair some sessions here. So kindly bear me with this. And yeah, the topic given to me and about what I will be talking is like air quality and climate change. So I would like to mention, firstly, a very good evening to all the participants. I mean, I'll try to engage them and I'll try to have some discussion one-on-one as well. Besides, I'll just try to talk about more about what is air pollution, about air quality, what are different types of air pollutants, and the basic takeaway from today's session will be, even if we get a bit aware about how much hazardous or how impactful air pollution is, that will be, I mean, I'll consider it as a success. So I'll also share the real-time experiences of air pollution recently, what I encountered in our country itself. So yeah, here I start. I'll be covering these are the content of my presentation: air pollution, its definition, then climate change, linkages, real-time experiences, and mitigation strategies for air pollution. So yeah, air pollution. How we define air pollution? It refers to the presence of harmful substances in the atmosphere, including gases, particulate matter, and biological molecules that pose risks to human health, other living organisms, or the entire environment. And this might result due to volcanic eruptions, wildfires, dust storms, and pollen are all natural source of air pollution. Apart from that, due to anthropogenic activities like industrial emissions, vehicle exhaust, deforestation, and burning of fossil fuels are all sources of anthropogenic pollution. Now, coming to other topic, climate change. Now, climate change refers to significant and long-term changes in average weather patterns, including temperature and precipitation across the Earth. It includes variations in temperature, precipitation, and wind patterns over decades or even longer duration. Now, how they are interrelated? So, air pollution and climate change are linked because the source of air pollution, like fossil fuel combustion, also release greenhouse gases that contribute to climate change. Besides, burning fossil fuels is the main source of air pollution, and climate change, releasing harmful pollutants that contaminate the air and contribute to global warming. Climate change exacerbates air quality problems by increasing temperatures, which enhances the formation of ground level ozone and also leads to more frequent and severe wildfires. Air pollutants like black carbon are potent climate forces that trap heat in the atmosphere, contributing significantly to global warming. Addressing air pollution can yield significant health benefits as it is responsible for millions of premature deaths annually due to respiratory and cardiovascular diseases. Now, the air pollutants are categorized into two parts, like primary air pollutants, secondary air pollutants. So in primary air pollutants, we consider carbon monoxide, sulfur dioxide, nitrogen oxides, and particulate matter. Again, how this carbon monoxide is released? It is emitted from vehicles and industrial processes due to combustion of fossil fuels. Sulfur dioxide, it is released from burning fossil fuels and industrial activities. Then nitrogen oxide, it is produced from vehicle emissions and power plants due to combustion of coal and fossil fuels. Like with particulate matter, microscopic solid or liquid particles suspended in the air, including dust and soot. Further, secondary air pollutants like ozone, smog, particulate matter, gaseous pollutants. The smog is a combination of smoke and fog, often seen in urban areas. Likewise, as we discussed, particulate matter, microscopic solid or liquid particles suspended in air, including dust and soot. Besides the gaseous pollutants, including carbon monoxide, sulfur dioxide, nitrogen oxide, and variety of other compounds. The VOCs these are basically formed from reactions between sunlight, nitrogen oxide, and variety of organic compounds. Ultimately, these are, categorized as secondary air pollutants. Now, considering the sources, like point sources, non-point sources, traffic emissions, industrial activities, agriculture activities, mining operations, power generation, natural sources like volcanic eruption, as we discussed. From the pictures, we can understand these are basically the sources of air pollution. Now, one of the major reasons what I found in recent times is burning of agro waste or parali, in other words, we say, or the whatsoever remains in the farmlands after harvest, which is, the practice of burning of this, I found as one of the major contributors for air pollution in our country. Now, again, ground level, these are the type, this slide explains different types of pollutant, putting a bit light on this. Particulate matter, these are the tiny particles suspended in the air, including dust, soot, and smoke. Again, it is categorized as PM 2.5 and PM 10. Then ground level ozone, represented by O3, a secondary pollutant formed by reaction of nitrogen oxide and volatile organic compounds in the presence of sunlight, contributing to smoke and respiratory problems. Then lead, a toxic metal that can be emitted from industrial processes and vehicle emissions, posing serious health risks, especially to children. Again, VOCs, organic chemicals that evaporate at room temperature and contribute to ozone formation. Common sources include paints, solvents, and vehicle emissions. For the ammonia, a colorless gas primarily released from agricultural activities, which can react with other pollutants to form particulate matter. Likewise, polycyclic aromatic hydrocarbons, organic compounds formed during the incomplete burning of organic materials associated with various health risks. Then hazardous air pollutants, toxic pollutants known or suspected to cause serious health effects, example including benzene, dioxins, and heavy metals like mercury. Now, global distribution of air pollution. People in East Asia and South Asia have the highest exposure levels, affecting 2.2 billion and 1.8 billion people respectively. China and India account for 38% of the global population exposed to unsafe air pollution, with nearly all facing hazardous PM 2.5 levels. High PM 2.5 levels persist in South Asia, Africa, and the Middle East due to industrial activities, residential fuel use, and natural dust. Economic development disparities show that middle income countries face higher pollution due to rapid industrialization and weak regulations. Over 90% of the global population lives in areas exceeding WHO's acceptable air pollution levels. These are some facts taken from the web. Low and middle income countries bear the highest burden, while high income countries have improved air quality and in recent decades. I would like to mention about the case of China. Normally, being the communist, country or nation, they normally not disclose the figures. But as per a documentary of Nat Geo, there is an entire city in, I can't recollect the name of the city in China, which is, filled with all of hazardous waste, where the air quality level is extremely bad and poor. However, as they celebrate that they have several measures taken to curb and to deal with air pollution in their other cities, but the scenario there is more worse as what is seen normally through reports or in in televisions we see. Further, major contributors of air pollution: transportation. Vehicles emit carbon monoxide, nitrogen oxides, and particulate matter through fuel combustion. Shipping and aviation contribute to greenhouse gases and sulfur emissions. Diesel engines release black carbon, a major short-lived climate pollutant. Now, talking about this, the recent example of the transportation are what you say, the tourist places here in India, like Himachal Pradesh or Jammu and Kashmir. We can see there are infrastructure development is being done or is being carried out at a higher pace in order to boost tourism. However, the adverse effects of those are found that these places which were earlier pristine and were considered as heavenly, now one can see traffic congestion due to affordability of the common masses. They are visiting these places with their own vehicles, and thus resulting into tremendous pollution in these pristine regions of our country. So now, energy production, another factor. Coal, oil, and natural gas combustion release carbon dioxide, sulfur dioxide, nitrogen oxides. Power plants emit particulate matter and toxic heavy metal like mercury. Renewable energy sources like wind and solar have minimal air pollution. Like, as you all might be aware, even today, about 70% of our energy demand is, sufficed by coal-powered thermal power plants. So the exhaust or other byproducts like fly ash contributes immensely to air pollution. Agriculture, livestock farming emit methane from digestion and nitrous oxides from manure and fertilizers. Crop burning releases particulate matter and carbon monoxide in the environment. Ammonia emissions result from fertilizer use and contribute to secondary pollutants. Due to like the winds, they carry through through vectors, it is carried to other parts, resulting into hazardous air pollution. Then manufacturing industries, factories emit VOCs, volatile organic compounds, NOx and SO2 during chemical production and metal processing. Cement and brick kilns or brick manufacturing industries release CO2 and particulate matter during its production. Industrial activities also discharge hazardous air pollutants like benzene and lead in the environment. Urban air pollution, we will be now highlighting with case studies of metropolitan cities in India. Kolkata, a study indicated that Kolkata experiences higher pollution levels compared to other Indian metropolitan areas like Mumbai, with vehicular emissions that is around 51.4% being the primary source, followed by industrial sources 24.5% and dust particles 21.1% contribution. The study highlighted that approximately 85% of respondents in surveyed dispensaries reported respiratory diseases, emphasizing the health impact of critical air pollution levels. Another, Delhi, which is one of the most polluted cities in the world now. Delhi faces severe air quality challenges, with studies showing a vulnerability index indicating medium to high stress due to air pollution in urban roadways and intersections. The formulation of an effective air quality management plan is crucial for addressing the health impacts on its urban residents. Likewise, considering Chinese cities, a multi-city study across 626 cities in China reveals that urban form and development levels significantly influence PM 2.5 pollution trends. The research suggests that different urbanization stages require tailored strategies to achieve long-term clean air goals. Brasilia, in Brazil, the rapid growth of the vehicular population in Brasilia has led to increased ambient air pollution levels, highlighting the impact of urbanization on air quality in capital cities. Global perspectives, according to World Health Organization, urban air pollution is a major environmental risk to health, contributing to approximately 4.2 million deaths annually due to exposure to ambient air pollution, underscoring the urgent need for effective urban air quality management strategies worldwide. So I will also share my other experiences from my personal experiences from other countries I visited, and I will present a bit about their comparison with our country. Now, indoor air pollution, we can take some example of cooking and heating, or household products, tobacco smoke, combustion appliances. Effects: exposure to indoor air pollution is associated with a range of health issues, including respiratory diseases, including asthma, bronchitis, cardiovascular problem, and even cancer. Both children and elderly individuals are especially vulnerable because of their developing or weakened immune system. Long-term exposure can lead to chronic health conditions and decreased quality of life. Poor indoor air quality can also contribute to sick building syndrome, where occupants experience acute health effects linked to time spent in a specific setting. Now, measurement techniques of air quality index and monitoring tools. The air quality index is a scale which is used in our country to measure the severity of air pollution. So air quality index, AQI, uses a color-coded system to communicate air quality and health risk. It measures pollutants like PM 2.5, PM10, ozone, carbon monoxide, sulfur dioxide, and nitrogen dioxide. AQI highlights health impacts for sensitive groups and varies by local standards. Low-cost sensors measure PM, carbon monoxide, and volatile organic compounds in real time but are less accurate. Satellite remote sensing detects pollutants over large areas and track trends. Likewise, the ground-based stations provide accurate localized data using analyzers and spectrometers. Likewise, mobile units collect air quality data in hotspots using sensors and analyzers. Integrated networks combine data from various sources for comprehensive analysis. Also, nowadays, we have numerous smartphone apps and variable devices providing real-time personal air quality monitoring and help raise awareness. As we can see here, the air quality index, as per the color code used by CPCB, if it is in the range of 0 to 50, it is good. If it is in the range of AQI in the range of 51 to 100, it is considered as moderate. Likewise, if it is in the range of 101 to 150, it is considered unhealthy for sensitive groups. Also, if it is between 151 to 200, it is considered as unhealthy. And if it is in the range of 201 to 300, it is considered very unhealthy. And if it is in the range of 301 to 500, it is considered hazardous. Now, the trick here is, recently we saw some news about Lahore, Islamabad, like the air quality index there, which was found in the range of 1900. Within the range of 1500 to 1900. I would like to mention this. In India, if it is up to 500, our scaling is up to only 500, and we don't go beyond that. Consider if it is 500, it means it is extremely bad, right? As per a recent trend, in yesterday's somewhere in news clip, I saw the current the status of air pollution in Delhi is like, smoking 50 cigarettes. So that is the severity of air quality in Delhi in recent week. Now, as per the guidelines and the standards, the permissible limit as per the different agencies like EU, European Union, World Health Organization, then as per our Indian context in China, these are a few of the the measures given here, like for particulate matter PM 2.5, 5 microgram per meter cube. As per the US, it is 9 microgram per meter cube annual. Also as per the European Union standard, 25 microgram per meter cube in 24 hours reading. Likewise, for for ozone, sulfur dioxide, carbon monoxide, and lead, it is given. Results of this air pollution, one can see aging skin, other like diseases related to lungs like asthma, lung cancer, bronchitis, pneumonia, also several other cardiovascular diseases. Besides, it also hampers insulin resistance and Mediterranean diabetes, blood clots, premature birth, low birth weight, decreased sperm quality, illness during pregnancy. There are all other factors resulting to air pollution. Now, what are the causes of climate change? We have categories here into two parts: natural causes, human causes. In natural causes, volcanic eruptions release large amount of carbon dioxide and aerosols affecting the climate. Solar radiation variations influence Earth's temperature cycle over a period of time. Ocean currents and patterns like El Nino impact global weather and temperature. Like with natural greenhouse gas emissions occur from wetland, wildfires, and permafrost thawing, etc. Likewise, the anthropogenic gas causes burning fossil fuels for energy generation, or open burning for energy release, and the deforestation reduces carbon sequestration, increasing atmospheric carbon dioxide levels. Likewise, industrial processes emitting greenhouse gases like methane, nitrous oxide, and fluorinated gases. Likewise, agriculture contributes emissions through livestock, rice paddies, and fertilizer use. Now, role of greenhouse gases and their global warming potential. Nitrous oxide emitted from agriculture activities, fossil fuel combustion, and industrial processes. It has a global warming potential of 273, indicating its strong heat trapping ability compared to carbon dioxide. It remains in the atmosphere for about 109 years, right? Methane released during oil and gas production, agriculture, especially livestock, and waste management. It has a global warming potential of approximately 27 to 29 over a 100-year period, making it much more effective at trapping heat than carbon dioxide. It has an average atmospheric lifetime of about 11.8 years. Likewise, another greenhouse gas like carbon dioxide, major greenhouse gas emitted from burning fossil fuels, deforestation, and land use changes. It has a global warming potential of 1 baseline for comparison. It remains in the atmosphere for hundreds to thousands of years, contributing significantly to long-term warming of the environment and thus resulting into global warming. Now we have to understand here the carbon cycle distribution and how it impacts its role in climate systems. The carbon cycle involves the movement of carbon among the atmosphere, biosphere, geosphere, and hydrosphere. It has two components: the fast carbon cycle, which takes place in years, and the slow carbon cycle, which takes around millions of years. Like human activity like burning fossil fuels and deforestation disrupt the carbon cycle. Also, atmospheric carbon dioxide levels have increased by nearly 52% since pre-industrial times. Increased CO2 contributes to global warming by enhancing the greenhouse effect. Disruptions can lead to climate change, ocean acidification, and ecosystem shifts. Then changes in one carbon reservoir affects the others, maintaining Earth's temperature balance. Geological processes also influence carbon levels but occur over much longer time scales. Understanding the carbon cycle is essential for addressing climate change effectively. Now, as we see from this diagram, we can see here through the process of photosynthesis, again, the carbon is consumed. Carbon dioxide is consumed by the plant in the presence of sunlight and chlorophyll to make its own food. Further, we also add on to this carbon dioxide in the environment through respiration. All living organisms respire aerobically, consume oxygen, and taking out carbon dioxide. Further, this cycle is balanced through the process of photosynthesis and respiration, and these are all interrelated activities. Apart from that, making imbalance through anthropogenic activities, again, like burning of fossil fuels or burning of agro residues, agro waste. Also, these greenhouse gases are released in the environment during the process of resource extraction, mining of fossil fuels, as well as other essential minerals, metals. Besides, erosion, soil erosion also leads to the release of this carbon dioxide in the environment. Further weathering of rocks, deforestation, volcanic eruption. These are all the factors which add on to release of carbon dioxide in the environment. Then climate feedback loops, again, positive feedback mechanism. Melting ice reduces Earth's albedo, causing more heat absorption and further ice loss. Thawing permafrost releases methane and carbon dioxide, intensifying global warming. Warmer temperatures increase water vapor in the atmosphere, amplifying the greenhouse effect. As we are aware about the greenhouse effect, it is just about the artificial, gas layers formed in the environment, which ultimately trap the heat, which entered the Earth ecosystem. It gets trapped, resulting into rising the temperature of the Earth's atmosphere. That we call it as like global warming. Negative feedback mechanism: increased carbon dioxide levels enhance plant growth, which can absorb more carbon dioxide. Higher temperature may lead to increased cloud cover, reflecting sunlight and cooling the earth. Ocean warming and can enhance carbon absorption, temporarily moderating carbon dioxide levels. Now, the 2023 IPCC report predicts a greater than 50% chance of global temperatures rising by at least 1.5 degrees Celsius. Till 2040. Global temperatures have increased by approximately 1.1 degrees Celsius since the late 19th century due to anthropogenic activities. Greenhouse gas emissions must peak before 2025 and be reduced by 43% by 2030 to limit warming of 1.5 degrees Celsius. The average global temperature has risen above 0.11 degrees Fahrenheit, around 0.06 degrees Celsius per decade since 1850, totaling roughly 2 degrees Fahrenheit, about 1 degree Celsius of warming. The rate of warming has accelerated since 1982, averaging about 0.36 degrees Fahrenheit per decade. Projections indicate if current trends continue, temperature could rise by 3.3 degrees Celsius to 5.7 degrees Celsius by the end of the century. Limiting warming of 2 degrees Celsius will still have significant impact, including more frequent heat waves and extreme weather events. Warming is not uniform. Land areas are warming faster than oceans, with the Arctic experiencing the most rapid changes. Immediate sustained reduction in greenhouse gas emissions are crucial to mitigate several climate impacts. Now, rising global temperature intensify the frequency and severity of heat waves. Increased atmospheric moisture leads to heavier and more frequent rainfall events. Drought are becoming increasingly intense in many regions due to changing precipitation patterns. Warmer ocean temperatures fuel more powerful hurricanes and tropical storms. Shifting jet streams result in prolonged weather conditions such as persistent heat or cold waves. Climate change exacerbates the risk of wildfires by increasing heat and drying out vegetation. Melting polar ice and warming oceans contribute to rising sea levels, intensifying storm surge and coastal flooding. Extreme weather events are occurring more frequently and impacting larger areas, posing significant risk ecosystem and communities. Now, causes of global sea level rise. Greenhouse gases added to the air by human activities. The planet gets warmed, ocean warms, and land ice melts. Water expands as it warms and takes up more space. Ice sheets and glaciers melt, carrying water to the oceans, and global sea level rises. Now, melting ice, Greenland loses approximately 270 billion tons of ice per year, while Antarctica loses around 150 billion per year. Thermal expansion, as seawater warms, it expands, contributing about 33% to global sea level rise. Land ice contribution, melting glaciers and ice sheets account for around 66% of the increase in sea level. Historical context, global average sea levels have risen by approximately 15 to 25 centimeter since 1900, with a current rate of about 4.62 mm per year. Now, what are the effects of rising sea levels? Increased flooding. Rising sea levels lead to more frequent coastal flooding, threatening infrastructure, ecosystem, and communities. Coastal vulnerability. Low-lying nations like the Maldives and Kiribati face existential threats from rising waters, risking displacement of population. Ecosystem stress. Coastal ecosystems suffer from rising sea levels, which disrupt habitats for fish and wildlife, and increase saltwater intrusion into freshwater aquifers. Economic impact: infrastructure such as roads, bridges, and water supplies are at risk, leading to potential economic losses in coastal regions. Now, what are the impacts of this climate change on biodiversity? Ecosystem disruption and species extinction. Climate change disrupts ecosystem by alternating habitats and environment conditions. With temperatures force species to migrate to cooler regions, often beyond their survival range. Ocean warming and acidification damage coral reefs, leading to loss of marine biodiversity. Changes in precipitation patterns impact freshwater ecosystems and aquatic species. Aerosols are small particles suspended in the atmosphere that influence climate. Cooling effects, scattering aerosols, particles like sulfates and nitrates reflect sunlight into space, leading to a cooling effect. Net cooling contribution, aerosols offset about one third of the warming caused by greenhouse gases, with a net cooling effect of approximately 1.3 watt per meter square. Like with warming effect, absorbing aerosols, black carbon, that is also called soot, absorbs sunlight, warming the atmosphere and contributing to localized warming. Overall impact of warming effect is significant, especially when aerosol is located above clouds. Causes of ozone layer depletion. Chlorofluorocarbons, main cause of ozone depletion released from products like solvents and refrigerators. Other ozone depleting substances includes hydrofluorocarbons and halogens used in various industrial applications. Natural causes, minor contributions from volcanic eruptions and stratospheric winds. Rocket launches. Recent studies suggest unregulated rocket launches may significantly contribute to ozone depletion. Impacts of ozone layer depletion: increased UV radiation. More UV radiation reaches the Earth's surface, leading to higher rates of skin cancer, cataracts, and immune suppression. Environmental effects: harmful impacts on ecosystems affecting plant growth and marine life, especially phytoplankton. Climate change interactions: ozone depletion may alter atmospheric circulation and temperature patterns as well. Now, black carbon. Black carbon is emitted from incomplete combustion of fossil fuels, biomass, and biofuels. Major sources include diesel engines, residential wood, and coal stove, and agriculture burning. Wildfire and industrial processes are also contribute to black carbon emissions. These are few figures I have taken where it was found that the black carbon contribution around 58% is from the household, transportation is only 24%, industrial production 6%, agriculture 5%, fossil fuels 3%, and waste burning 1%. Warming effect: black carbon absorbs sunlight, directly warming the atmosphere. It reduces the albedo of snow and ice when deposited, accelerating melting. Black color contributes to regional warming, especially in the Arctic and Himalayan region. Its short atmospheric lifespan means its warming effects are intense but temporary. Acid rain, what are the results? What causes acid rain? Nitrogen oxides and sulfur dioxide released from vehicle emission and industrial activities combine with their water vapor to form nitric acid. And this nitrous oxide is a potent greenhouse gas with global warming potential of 300 times than that of CO2. NOx contributes to the formation of tropospheric ozone, which is a short-lived climate pollutant. Excess nitrogen deposition in ecosystem alters biodiversity and disrupts carbon storage processes. Industrial emissions release large amount of carbon dioxide. The primary gas driving global warming. Emissions arise from direct fossil fuel burning and indirectly electricity consumption in indirect industrial activities. Key greenhouse gases include CO2, CH4, N2O, and fluorinated gas. Cement, steel, and chemical sectors such as we account for around 20% of global carbon dioxide emissions from energy and processes. The industrial revolution has led to release 2.3 trillion tons of greenhouse gases. Industrial emissions have raised global average surface temperature by about 1.1 degrees Celsius. Mitigation strategies include greener energy, improved efficiency, and carbon capture technologies. Industrial energy use is projected to grow by 75% by 2025, requiring urgent emission reduction efforts. Global initiatives like the Paris Agreement focus on limiting temperature rise and reducing the emissions. Like from the agriculture and climate link, livestock farming contributes 14.5% to 15 to 19.6% of global greenhouse gas emissions. Methane and nitrous oxide from livestock are significantly more potent than CO2 in warming the planet. Methane from enteric fermentation in ruminants is 28 times stronger than CO2 over century. Livestock farming produces 60% of global nitrous oxide emissions with 296 times the warming potential of CO2. Feed production, management, land use changes and significantly to livestock related emissions. Cattle ranching drives 41% of global tropical deforestation, amplifying greenhouse gas emissions. Rising demand, especially in developing countries, could push global warming beyond 1.5 degrees Celsius. These are the contaminants like trace metals, radionuclides, nutrients, organic contaminants, plastics. And it gets spread due to all these things like floods, storm surge, dust storms, hurricanes, heat waves, droughts. Tropospheric ozone level has risen from 10 to 15 ppb to 30 to 40 ppb parts per billion, becoming the most widespread forest air pollutant. Critical nodes for acid deposition and ozone have been exceeded in many European forests, causing defoliation and tree health decline. Acid rain from power plants and agriculture leaches essential nutrients like calcium, damaging forest health. Air pollution disrupts forest ecosystems, leading to diversity loss and decline in key species. Pollutants alter tree physiology, making them more vulnerable to pests and diseases. This you can see normally in the areas of Haryana, Punjab, Delhi, and outskirts of NCR region, where this effect of the ash, which is which flows away with the winds or in the air, it gets deposited on the surface of the trees and plants, right? Changing the physiology. Then again, result of this air pollution in acid rain formation, like SO2 and NOx from air pollution mixed with the water vapor, forming sulfuric and nitric acids that cause acid rain. It also results in other water quality issues like acid rain lowers the pH of rivers, lakes, and streams, harming fish and aquatic life, disrupting ecosystem. Eutrophication, it encourages eutrophication. Nitrogen from air pollution causes eutrophication, leading to excessive algae growth from nutrient overload in water bodies. Algal blooms, when algae decompose, they reduce oxygen levels, creating dead zones where aquatic life struggles to survive. Toxic risks, some algal blooms produce harmful toxins, posing threats to both human health and wildlife. Long-term effects, like acid rain and eutrophication, can alter aquatic ecosystem for years, impacting species diversity and composition in the concerned area. Now talking about like soil health and fertility, soil acidification, air pollution causes acid rain, lowering soil pH and harming overall soil health, right? Which will ultimately hamper the soil productivity. Nutrient loss, increased acidity makes it tough for plants to get essential nutrients like calcium and potassium as a leach out of the soil. Toxic metals, acidic soil can release harmful metal like aluminum, which can damage plant roots and mess with nutrient absorption. Microbial impact, acid deposition disrupts crucial microbial communities that help with nutrient cycling and breaking down organic matter, leading to poorer soil quality. Plant growth issues, with fewer nutrients available and more toxic elements, soil acidification stunts plants growth and affects forest health over a period of time. Biodiversity loss reduces ecosystem stability and resilience, threatening vital ecological functions. Over a million species are at risk of extinction due to human activities, with amphibians, corals, and mammals most affected. Since 1970, vertebrate populations have dropped by 60%, mainly due to habitat loss from agriculture and urbanization, especially impacting freshwater species. Pollution harms biodiversity by causing health problems in organisms, including reproductive issues, and higher mortality rates. Then invasive species disrupt local ecosystem by outcompeting native species for resources, worsening the biodiversity loss. Climate change shifts species distribution and also alters ecosystem, making adaptation extremely difficult and complex for many species. Then it also again results in like the change in migration pattern of the birds and other amphibians, species on the move. Over half of species are shifting habitats due to climate change, moving north or to higher elevations for cooler climates. Timing is off, like many animals are migrating and breeding earlier than usual, affecting the survival and reproductive success. Different reaction, not all species react the same way. For example, mules here in the American West are adjusting migration timing to match food availability. Arctic challenges, Arctic animals face significant changes due to melting ice and unpredictable weather, disrupting predator-prey dynamics. Then caribou migration woes, warmer temperatures are delaying caribou's fall migration, disrupting their usual cues linked to colder weather and snowfall. Impact on ecosystem, the decline of migratory species can disrupt ecological balance, impacting essential services like pollination and nutrient cycling, highlighting the need for conservation efforts. Further, it again impacts the crop yield. Soil fertility is declining due to pollution, leading to lower crop yield, as highlighted in various studies. Pest and plant diseases are on the rise, worsened by changing weather pattern, resulting in less productive crops. Climate change is causing more extreme weather events like droughts and floods, which directly cut down on crop yield. Higher temperature can hurt crop production, and it impacts especially in tropical and subtropical areas where conditions are already pretty ideal. Then changes in rainfall patterns are causing water issues, either too much or too little, which seriously impacts crop productivity. Human activities, including pollution and poor farming practices, account for up to 60% of the differences in crop yield losses in different regions. Further, there are several case studies like Amazon deforestation, Arctic warming and black carbon, Delhi air pollution, coral reef degradation, California wildfire. Like Amazon forest, cattle ranching causes 80% of Amazon deforestation, increasing greenhouse gases and habitat loss, with over 20% of the forest already gone. Considering Arctic warming, black carbon from burning fuels and in the form of soot and biomass settles on ice, absorbing more heat, and accelerating Arctic warming, leading to melting ice caps and rising sea levels. Further, in Delhi, vehicle emissions and crop burning cause hazardous air quality, health problems, and visibility issues, prompting government actions like vehicle restrictions. Coral reef degradation, rising sea temperature and pollution are stressing corals, causing bleaching and loss of marine biodiversity, threatening coastal protection and local economies dependent on tourism and fishing. For the California wildfires, prolonged drought and urban expansion are increasing the frequency and intensity of wildfires, destroying lives and property, worsening air quality, and contributing to climate change through carbon dioxide emission. Further, I'll be showing you some real-time video you can see which are recorded. Recently, in last, I mean, again, couple of months, as I told you, I have been traveling from last few weeks. In last couple of months, I visited several parts of our country, like Delhi, Haryana, Punjab, Jammu and Kashmir, and now I'm in like here in Surat, in Gujarat. So I would like to, discuss here or mention here the problem of air pollution is extremely severe. And while I was in Punjab and Haryana, I doubted whether I was in our same country or I am in some backward country like African country, somewhere like that. Because you know the problem of air pollution, you will get a glimpse from this video. I hope it plays and it is visible to you all. As you can see, these are recorded while we were, traveling through car. The surprising thing is, the surprising element is that the common masses, they consider this as, you know, normal fog. They don't have awareness considering about the smog. So they just think like this is just a normal fog and it usually appears every year. And they are so habituated that they say that it is nothing but just, we experience this thing every year because of this parali burning in this duration, and they got accustomed to this thing, this practice, and that is more disheartening. Another video, this one, what I recorded, you can see the small farmers, and it is evident even now in Punjab and Haryana. When you travel, you will see this kind of pictures, right? This scenario, they literally burn at night time, and the situation gets worse. I mean, more worse. So this was while we were traveling from Haryana to Punjab, daytime, and this is during the night time. And the next video I'll be showing, it is around, about while returning from Punjab to Haryana. So you can see our driver was just focusing on the vehicle which was which was ahead of us, and observing their indicator and the brake lights. We were traveling, just imagine. Again, another shocking as well as surprising truth in India. When the normal speed is of like 60 kmph, so we cover a distance of 60 kmph in 1 hour. So the distance between Haryana and Punjab, our source and destination, the cities, selected cities, was around 360 kilometers. Ideally, one should reach, so if one starts from the source to destination, covering the distance of 360 kilometers in 6 hours. But imagine we took almost 14 hours to cover this distance, and that was so disturbing for me. You cannot imagine, throughout night we didn't slept. The driver was continuously driving, and we were just like encouraging him, like we are also awake. It was such a disheartening situation, and I felt so helpless there. That time I understood. We normally study or read about air pollution, but when I experienced this thing, I felt pity for the people who are residing in these areas and how these people are living. So yeah. Now, concluding this, I will be talking about the mitigation strategies for air pollution. Like global agreements like Paris Agreement, we know, which aims to keep global warming under 2 degrees Celsius, encouraging countries to set their own emissions reduction goals for better accountability and air quality. Another one, Kyoto Protocol created binding targets for developed nations to cut greenhouse gas emissions from 1990 levels and introduce flexible market mechanisms to make reductions more cost effective. Montreal Protocol focuses on phasing out ozone depleting substances like CFC, chlorofluorocarbons, leading to major successes in reducing these harmful chemicals and improving air quality overall. Emission control technologies advocates for cleaner tech in industries and power plants to cut down emissions of harmful pollutants like sulfur dioxide and nitrogen oxide. Transportation improvements encourage the use of electric vehicles and better public transport while pushing for stricter emission standards on vehicles to reduce air pollution. Community engagement stresses the importance of involving local communities in air quality management to ensure effective strategies and compliance with the regulations. Besides, air quality monitoring combines policies, strategies, and regulations to control air pollution. It focuses on reducing emissions from vehicles, industry, and agriculture, where like public engagement helps identifying local air quality issues. Besides, technological innovations promote clean energy and reduce emissions. Further, sustainable transportation improves public transit and low emission zones. Solid waste management reduces landfill emissions through recycling practices. But the regulatory framework set and enforce air quality standards. Continuous monitoring and public reporting raise awareness. This is the ultimate motive. The common masses should be aware, and then only he or she will feel the severity of this and will take measures to reduce or circumvent the issues related to air pollution. Now, how we can transit this thing? Like nowadays, we see there is a major shift observed in the common masses. Now, people are shifting from from fossil fuel powered vehicles to electrical vehicles. Now, from one perspective, it is good since it will not emit any kind of carbon monoxide or any harmful gases. But on the other end, the perception of the common masses is that since the petrol is quite expensive, so that the unit of electricity costs only 7 rupees or 8 rupees, depending on the different the charges in different states. They get more efficiency, more mileage. However, on the other hand, they should understand the electricity which they are getting or they are consuming is basically generated from the burning of fossil fuels like coal, diesel, petrol at thermal power stations, right? So yeah, cutting emissions, switching to solar and wind energy significantly lowers greenhouse gas emissions, helping fight global warming. Less fossil fuel dependence, moving away from fossil fuel reduces reliance on carbon heavy energy, enabling better efficiency and renewable infrastructure. Path to net zero, achieving net zero emissions by 2050 requires ramping up renewable energy, improving energy efficiency, and electrifying transportation and heating sectors. Global teamwork, the Paris Agreement emphasizes global cooperation to cut emissions through renewable energy and sustainable practices. Innovative technology, the transition involves adopting clean hydrogen and carbon capture technologies to reduce emissions in hard to decarbonize industries. And building resilience, going renewable helps cope with climate impacts, supports sustainable development, and provides clean energy to remote areas, improving living standards. Again, mitigation strategies involve green transportation, industrial regulation, emission control technologies, afforestation, plantation of trees should be done, so that we generate carbon sinks. Waste management practices, reducing methane emissions, so that the waste should be managed at the source itself, or rather we should have decentralized plants so that minimal waste reaches the landfill site. Then technology for pollution control, scrubbers, filters, and carbon capture should be installed, right? Then public awareness campaigns, education and citizen participation, role of government and NGOs, policies and on-ground actions should be taken, right? Then some other strategies like carbon pricing. Nowadays, we have a concept of ESG, industry, environment, social governance, where we nowadays practice this carbon carbon trading or carbon credits, right? This concept is nowadays taking a lot of hype. Then it's a strategy to cut greenhouse gas emissions by putting a price tag on carbon emissions, mainly through carbon taxes and cap and trade system. For example, I would like to give a basic example. If I ask you for how much rupees you get 1 liter of drinkable mineral water bottle, you will answer 20 rupees. But suppose if it is tagged or it is labeled with the amount of carbon emissions it has released, then gradually people get aware. I mean, instead of purchasing water, people will think of carrying their own water from their houses, right? Then carbon tax. This tax, measure like carbon tax. This tax charges a fee for every ton of carbon dioxide emitted, pushing businesses and consumers to adopt cleaner energy and boost efficiency. Further, the money collected from carbon tax can fund renewable energy projects to be returned to taxpayers, helping offset any higher energy costs. This method caps total emissions from certain sectors and allow companies to buy and sell emission permits, giving them flexibility in how they manage their emissions. Further, in a cap and trade system, companies that cut emissions more efficiently can sell their extra permits, creating a market-driven approach to reducing overall emissions. With over 60 carbon pricing initiatives worldwide, countries like Canada, China are leading the chart in implementing these programs to help tackle global emissions. Likewise, residential energy upgrades. The UK's Green Homes Grant funds retrofitting homes to improve energy efficiency, aiming for a 15% energy use reduction by 2030, especially for lower income households. India's industrial efficiency mission, the national mission for enhanced energy efficiency, incentivizes industries to reduce energy consumption through a scheme for trading energy saving certificates. China's energy intensity goals. China aims for 13.5% improvement in energy intensity in key industries by 2025, focusing on upgrading electric motors and transformers. Further, community education initiatives, programs like energy clubs in schools educate kids on energy conservation, while campaigns like India's Ujala scheme promote energy saving LED bulbs. Also, tech innovations in buildings, retrofitting older buildings with modern insulation and smart technologies like smart meters help homeowners efficiently monitor and manage their energy usage. Further, building resilience in vulnerable regions. Likewise, climate smart agriculture, sustainable farming practices, drip irrigation, sprinkler irrigation, such kind of practice should be adopted. Sustainable urban planning, green buildings and smart cities. I mean, utilizing the natural resources like sunshine hours. In this way, urban planning should be done. International collaboration, role of United Nations framework for climate change and global partnerships, monitoring and research, satellite systems and modeling tools. In community involvement, grassroots movements and local actions. These are essential, further, again, in concluding, these are the references which I've used here for my presentation. Again, glimpse of my Earth Lab at IIT Indore. These are glimpses of my research interest and ongoing projects. And finally, I mean, apart from these are other current ventures. This is the book series what we have with Taylor and Francis. Apart from that, out of these 4 books are in the process of publication at that stage. And any of you interested can contribute and can connect with me on LinkedIn. With this, I stop here with a quote: "In an underdeveloped country, don't drink the water. In a developed country, don't breathe the air." It was quoted by Jonathan Ravelban. And now I am open for questions if you have any. Thank you. I am unable to hear. I cannot hear you now.
Thank you so much, sir, for a wonderful session on air pollutants and their mitigation. I would like to open the session for any questions from the participants. If they would like to interact with sir, please you can unmute your mics or you can also type in the chat box. Sir?
Yeah.
Indeed, it was a wonderful session with you interacting over such a long time. And I'm really thankful to you that you could take time out of your busy schedule. Although you are traveling, still you could manage time. And indeed, it is very inspiring the way you work, so much energy you put into your work. It's always inspirational for us. Thank you so much, sir.
Thank you. So,
thank you.
Still, any of you have any queries or anything, you people can connect with me on LinkedIn or you can mail me. I mean, you can search on Google and you can directly write to me for any. I'm open for any type of collaboration or any type of joint events, right? So so signing off here. Thank you again, IPS, all the coordinating team and Professor Devanshi Jagwani, and entire team at IPS Indore. Thank you for the opportunity. Looking forward for further collaborations. Thank you.
Thank you so much, sir. Indeed, I would like to add on that Ashutosh sir is really humble. You can approach him anytime with anything, and he's always ready to help you out. Thank you so much, sir, from all of us over here. Participants, thank you for attending the sessions. Till now, you have been really energetic and helpful to us by attending actively. So we are looking forward to the last day of this faculty development program tomorrow. We'll be joining in the afternoon at 2 p.m. and we have international speakers lined up for you. So we hope to see you again tomorrow with the same energy as you have been contributing till now. See you soon and have a good day. Thank you.
Thank you, ma'am. Thank you so
Thank you, ma'am.